Okay, so welcome to pre-algebra. This is the first lesson in the first chapter. So way up high on your very first page in your concept book, you are putting a box with chapter 1, integer operations. We do that for each new chapter. On the very top line, we're going to put the lesson name, and you underline that. This lesson is 1.1. which means chapter 1, section 1, expressions and order of operations. You underline the lesson. If you have the materials available, you could even highlight this lesson title. When it comes to test day, I ask you to turn in your concept book with a book. I'll tell you how. It will be an assignment. You're going to put it right here on this first page of chapter 1. And then I'm going to go through and see that you have complete notes for every section we've covered in the chapter. And you get credit for that. So it's good for you because you're involved with the lesson as we're going through it. And then I am holding you accountable by checking you at that time when we get to test time. So if you're absent, you could come to the website, watch the video, and take notes just as you would in class. The difference is you'll have to pause the video so that you can write stuff down and try stuff. And you don't have to do that now since you're in the live class. Okay? The page number that the lesson begins on in your textbook is what is in parentheses after the lesson name. So up there, number 5 means that this lesson starts on page 5 in your textbook. And I just put the beginning page, the first page of the lesson. Begins on page 5. Yes? Okay, so as you know, in the concept book, we place important concepts that we all need to understand the vocabulary for. We're speaking this language of math, so this is how we do it. We make sure you understand the words so you can work with those in math. So powers. What comes to mind when you hear that word powers? What do you think, Michael?
Exponents.
Exponents, right? So often exponents. What operation is happening in a power? Rishi? Multiplication. And it's not maybe just one time, it could be like repeated multiplication, right? So powers are ways to show repeated multiplication of the same factor. That power there is 3 to the second. Who knows another way? Raise your hand if you know another way to say that power.
3 squared.
Good job. 3 squared, she said. And so what number is being repeatedly multiplied here with this here? 3. And it's 3 times what? 3 times what? 3 times 3, right? So what might a third grader think that was? Because there's a logical other thing you might think this is, right, Trevor? 3 times 2, right? But we never learned that using an exponent is a shortcut way to show multiplication of 3 times 2. Right? We learned instead last year that powers are repeated multiplication of the big number. 3 is happening 2 times. Okay? Let's look at a different power. This is a power of 6. So, what do we call I think it's easier to look at the 3 first. What do we call that little 3? Somebody already said it today.
Cubed.
He's saying one way to say it is cubed. That's true. It's like a cubing thing, and we call it the exponent, okay? And what does the exponent tell you in this case? That 3 tells you what?
How many times for 6 to multiply by 6?
Right. How many times 6 is being multiplied by itself, I guess, right? 6 times 6 times 6. 3 of them, okay? So the exponent tells you how many times the base is a factor. So what are we calling the 6? If 3 is the exponent, 6 must be the base. And it's kind of in that other definition, isn't it? So the base is the number that is being multiplied over and over. So there are a few questions that we could ask about powers. I mean, one question would be, let me use a simpler power than the 6 to the 3rd, because I think that's going to show up in an example anyway. So how about 3 to the 4th? Okay. So if I have 3 to the 4th, one question I could ask is, can you write that in expanded form? So who here could answer that one? Matt, is it Matthew?
But 3 times 3 times 3 times
Very good. 3 times 3 times 3 times 3. There's expanded form. This first form here is called exponential form. It's written with an exponent. The next form is called expanded form. And then finally, how else could we write this expression?
3.
What could we do with it? We could write it with words, and you're going to have to do that today. That's my least favorite thing. The thing I love about math is that we write as little as possible. So everything is in the shortest symbolic way we could put it, right? But there are those rare days like today where you're going to be asked to write that in words. And how would you write that?
Like, spell out 3.
3,
Would you spell out numbers too?
2,
Oh, yeah. 3 to the power of
you could write power of 4, or maybe just shortcut, we could say fourth power. I don't know. 3 to the 4th power. You will have to do that. What else could you do? What other answer could you get?
3 to the 2nd power plus
3, he said 3 to the 2nd power times 3 to the 2nd power. And that's true. It is that. And so there's probably a lot of ways we could do this. What else could we say? More simply. Is there a simpler way to say that? Matthew?
3 times 3 times 3 times 3.
Okay, well, I don't want to write things out anymore. Could you actually find the value of 3 times 3 times 3 times 3?
Yes.
You probably could, right? And so what is 3 times 3?
9.
So we really have 9 times another 9, right? And so this most simple way to say this is
81.
81, right? So you could actually be asked to evaluate, find the value. And that would be 81. So there's a lot of different questions we could ask. I want you to take this expanded form, jot it down, and then write that as a power, which means exponential form. Okay? Take this expanded form and write it now in exponential form. And I need a couple volunteers to come up and do this. If you're at home, do it, and then come back and check your work with us. And we're doing a good job here. We have 7 to the 6th, and we have 10 to the 4th, 24 to the 2nd, and 1 to the... Thumbs up if you agree. 1 to the 7th. Very good. And what is 1 to the 7th? Let's evaluate that. 1 to the 7th is 3, 2, 1.
7. 1.
Did you hear that? Did you hear that? 1 to the 7th is? 1. Right. Remember, this is not a way to show shorthand multiplication. We don't go 1 times 7. If that was a way to show multiplication, you would have learned that in 3rd grade. This is not the same. We do not multiply the base to the exponent. Okay? So be really careful. Can anybody evaluate this one, this power of 10? 10 to the 4th. What would we get when we actually find the value? Bridget? Is it 50? So I don't know how you're getting that one, because, what expand, oh, it's already expanded. Do you see this? What is 10 times 10? 100 right there. And here's another 100 right here. Right? So 100 times 100 is the question.
10,000.
What is that?
10,000.
10,000. And so what do you notice about this power of 10 and the exponential power of 10? What do you notice about these two?
It's 4 times 6.0.
Exactly. So when you're dealing with a power of 10, you just look at that exponent and you now know how many zeros are in your power of 10 that's written in standard form. It's 10,000. So it makes sense. Think about this. 10 squared, we already just said, equals
100.
how many zeros does 100 have?
2.
You see it matches up with the exponent, right? 10 to the 3rd then would be
1,000.
exactly 1,000, and so there you go again, 3 zeros. So really an important concept, and it comes up when we write in scientific notation, okay? Okay, let's talk about evaluating these things. If you're ready to turn a page, then do write on the back of the page. The goal, the ultimate ideal would be to contain everything you've learned in 7th grade math in one concept book. That's hard for most people. It's difficult to fit everything in one. Somebody in here might do it though. You might be writing that small yet legible, right? So you want to use every side of every page, try to keep it concise. And then if you need a second book, then we get a second book later in the year, okay? So now we're going to evaluate. We just did that with the power of 10. Evaluate means to find the, well, find the answer. There could be a lot of questions asked. So find the, there's a little word in here. Find the value, right. Find the simplified value. I guess I'll go this way. So now you are seeing scientific, or you're seeing exponential notation. There it is, a power with exponents. And you're asked to actually find the real value. I don't want you using calculators today for this. You should be able to do this in your scratch work, okay? So to do that, we might take this power of 6, which I had as a sample earlier, right? And what could we do with it to help us get started? Mickey? Is it Mickey? Mick. Okay, so he's actually saying, he's kind of expanding it, and he said you get 36, and he said you times it by 6, right? And so that's where you might want to go use your scratch paper, find a little spot to do 36 times 6. And what do you get, Mick, when you do that? Everyone go do it. We could do it quickly here. Do you have? Yeah. It's impressive to see so many people trying, okay? Because the more you try, the greater your effort, the greater your ability will be. So you're working it out. And what is 6 times 6?
36.
And 3 times 6? 18 plus 3 is 21. So it looks like 216. 216. Okay. How about 2 to the 5th? If you need to, again, expand it. How many 2's will we have visible now? Either 5 of them. 1, 2, 3, 4, 5. Okay, and you can start grouping. 2 times 2 is 4. And here's another 4. And then I have that other last factor of 2. And now, what do you get, Ethan? 32. Good job. Okay, try these and we'll come back and check it. Come back and check after you've tried them. Okay, so now we get to this interesting 13 to the 0. In math, 0 is so interesting. It creates all kinds of issues and special cases and things like that. So 13 to the 0, what do you think that is? 13 to the 0. 0. Thumbs up if you agree. Could it be 0? And I would say 99% of the class is agreeing. Do we have any other possible answers? If it wasn't 0, what could it be? It's not 0. So what could it be? Let's have another guess. 13. That's logical. Who agrees with her? Could it be 13? Now, didn't we just say 3 to the 1st is 3? So could 3 to the 0 also be 3? If 3 to the 1st is 3, 3 to the 0 is also 3? Seems like it should be different, doesn't it? And it is different. It's not 13. It's not 13 and it's not 0. And those are the numbers you see here. So what could it be?
It's nothing.
He says nothing. It is something. It's an actual real number. 13 to the 0 is
Negative 13.
negative 13. Another logical try, and unfortunately it's not negative 13. So what could it be? Yes?
Maybe it can be broken down and the answer is just 13.
So it just has to stay that? No, you can actually call it a simpler, you can evaluate it. You can say what it is. It is, it is, it is not, but that's a great try. One more try? You're right, it's 1. How did you know? Because she said,
I said it for Lizzie.
and
So Lizzie.
you tried something else earlier, right? And so she's trying again, but she's thinking of what makes you think 1? Isn't it interesting? Okay, it's 1 for a very good reason, and I can show you the math behind it, but it involves negative exponents. And have you dealt with negative exponents yet? Okay, so we will talk about it when we talk about negative exponents. Any number to the 0 is 1. Any number to the 0 is 1. It really is 1. Take my word for it, and we'll explore that further with negative exponents. So now let's try 10. Look at 10. 0 to the 3rd.
1.
Oh, who thinks it's 1? Who thinks it's, I heard 0. Who thinks it's 0? And 99% of them are agreeing. And they're right, it is 0. 0 to the 3rd.
I was right.
It's 0, it is. That one's not as hard as the other one. Okay? Okay, numeric expression. A numeric expression has what? What do you think it has? If it's a numeric expression, it must have numbers. That's right. Statement with numbers and operations. So if I am solving a statement with numbers and operations, and it has more than one operation, then we need to know what is the proper order of operations. And you have already learned an acronym that helps you remember the correct order of operations. And that is, let's say it together, 3, 2, 1.
PEMDAS.
All right, so we're going to review that right now, PEMDAS. There's a sentence that I just heard, which is, please excuse my dear Aunt Sally. So that's one way to remember it, but PEMDAS is the way most people remember it too, just saying that little acronym. And so let's talk about what you would do first. If you have a huge problem with lots of stuff in it, what does P stand for, Carson? Parentheses. And parentheses aren't the only type of grouping symbol. So I always like to say grouping symbols first. You might have brackets. You might have parentheses inside of other parentheses or inside of brackets. You might have a big division bar. So you might have 3 plus 2 all over 5. And the division bar is a grouping symbol. So you could put parentheses here, but you don't have to put parentheses because the division bar itself is a grouping symbol. Keep that in mind, that's really important. After simplifying your parentheses, we move to E. E stands for?
Exponent.
Right. So any powers, simplify them. The next 2 letters I like to circle because you would deal with either of these operations, right? Depending on which one comes first, left to right. And these operations, Sarah? Multiplication or division. And it's whichever comes first as you read it left to right. And then finally, the last operations you're looking for, which you could circle as well, are represented by the A and the S. And Hannah, what are those operations?
Addition, subtraction.
Right, whichever one comes first, left to right. Okay, so go ahead and try these and come back and check your work with what you see in our notes. Notice he simplified the innermost parentheses first, and then the next group, and finally 12 minus 11 was 1. So, good job. This is what it should look like. No equal signs. And there you go. You may begin.